Today's learning objective, students use deductive reasoning to form a logical argument. So deductive reasoning is when we use facts, definitions, accepted properties, and laws of logic to form a logical argument. So when you think of deductive reasoning, think of logic. And if you remember before when we talked about inductive reasoning, with inductive reasoning, what did we use to make a conjecture? We looked for a pattern. Okay, so deductive reasoning uses logic, inductive reasoning uses patterns. So we have a couple of laws of logic. The first law of logic is called the law of detachment. And what the law of detachment says, it says if P then Q is a true conditional and P is true, then Q is true. And so you will be given one if-then statement, so if P, then Q, and then you'll be given another statement that satisfies the hypothesis, just P. So you're starting off with only one if-then statement. And so if we are given that if P then Q is true and P is also true, or in other words the hypothesis is satisfied, what we can conclude then is that the conclusion is also true. So the law of detachment, you end up with a detached set of statements. P and the Q are detached from each other. So that's another way of remembering it. The law of syllogism, that's not going to work. The law of syllogism says that if P then Q and Q then R are true conditionals, then P then R is true. So for this one, you are going to be given two conditional statements. You're given if P then Q, and you're given if Q then R. And so you start with two if-then statements. Okay, so you start with two if-then statements. And so your conclusion that you could draw is if P, then R. Okay, so let's start with some examples for the law of detachment first. Okay, example 1. If two numbers are odd, then their sum is even. 3 and 5 are odd numbers. So the original if-then statement is a general statement. If two numbers are odd, then their sum is even. Then following it is a more specific statement that has to do with the hypothesis. So two numbers are odd. That is our hypothesis. Their sum is even. That's the conclusion of the if-then. Now, 3 and 5 are odd numbers. Is that referring to the hypothesis, or is it referring to the conclusion? Well, it's referring to the hypothesis. It's saying in this specific case, when I'm talking about 3 and 5, those are odd numbers. So what can I conclude? I can conclude that the sum of 3 and 5 is even. Okay, so we start with the general and move to more specific. If two numbers are odd, then their sum is even. 3 and 5 are odd numbers, therefore the sum of 3 and 5 is even. So the pattern that we went was PQ, PQ. Okay, and it's always going to be this pattern in order for it to be a valid conclusion. Let's take a look at example 2. Okay, so in example 2, if a vehicle is a car, then it has 4 wheels. So a vehicle is a car is our hypothesis. It has 4 wheels is our conclusion. So if I look at this specific case, the sedan has 4 wheels. Well, is that referring to the hypothesis or the conclusion? 4 wheels was part of the conclusion. So this one is not following the right pattern. It's not going PQ, PQ. It's going PQQ. So that doesn't work. We can draw no valid conclusion. Okay, so just because something has 4 wheels does not mean that it has to be a car. It could be a quad, or it could be a baby buggy, or there's lots of things that have 4 wheels that aren't cars. So there's no valid conclusion that you can draw from this. Okay, law of syllogism. We start off with 2 if-then statements. If it's raining, then it's cloudy. If it's cloudy, you can't see the sun. So if we look at this, if it's raining, that's P. Then it's cloudy, and that's going to be my Q. Now the next statement starts with the Q. If it's cloudy and has a third statement that we haven't seen before, you can't see the sun. So that's one we're going to call R. So what I can conclude, again, the law of syllogism says if P then Q and Q then R are true statements, I can conclude that if P then R is true. So I'm going to take out the middleman, essentially, and say if P then R. So if it's raining, you can't see the sun. If P, then R. Now let's take a look at another example. If 2 angles are vertical, then they are congruent. If angles are vertical, then their measures are equal. So if angles are vertical, will be P. They are congruent would be Q. If angles are vertical, that's going back to P. And their measures are equal. That's something new altogether. So if you look at what's in the middle here, there is no middleman. Those are different from each other. And so because they're different, I can't take them out. There is no valid conclusion. Okay, so it didn't go PQQR, it went PQPR. Doesn't follow the right pattern. There's no valid conclusion that you can draw. All right, example 3. If you go to the movies, you'll eat popcorn. If you finish your homework, then you'll go to the movies. So initially, when you look at it, it doesn't look like it's following the pattern. Because when I'm looking at the middle two, you'll eat popcorn and finish your homework, those are different. But I noticed that go to the movies is in there twice. And so if I rearrange these sentences and move the second sentence first, if you finish your homework, you'll go to the movies. If you go to the movies, you'll eat popcorn. Now it meets the pattern. Here's P, here's Q, here's Q again, and there's R. So I can actually conclude, if you finish your homework, you'll eat popcorn. Because I was able to take out the one that was the same in the middle. Okay, so when we're using inductive and deductive reasoning, you want to keep straight which is which. So just to remember, inductive reasoning, you look for a pattern and make a conjecture. Whereas deductive reasoning, you use logic to draw a conclusion. Okay, and by logic, I mean facts, definitions, law of detachment, law of syllogism, and so on. So I've got two examples, and we're going to decide whether it was inductive or deductive reasoning that was used. So part A, for the last 3 weeks, Natalie has watched The Neighbor's Boys on Friday night. She concludes that she will watch them this Friday. And part B, Natalie's neighbor calls her and asks her to babysit the boys on Friday, therefore Natalie will watch them this Friday. So, looking at A and B, decide what type of reasoning was used for each of them. Pause the video as you think about it, and then when you're ready to find out the answer, turn it back on. Alright, so example A, Natalie was looking at what had happened for the last 3 weeks. She hadn't actually gotten a phone call yet on part A. She was just looking at a pattern. And so because she was looking at a pattern of every Friday on past 3 weeks, babysitting, that is inductive reasoning. Okay. However, on example B, her neighbor called her. We have a fact now. We have not just a pattern that we're looking at. We have facts. And facts are part of logic. And so this would be deductive reasoning. Okay. And that concludes this video. Thank you.